Kia ora Year 12 and Year 11. I'm going to do a few questions from class today because there were 5 of you away, and anyone else who missed out on these in class can catch up. So the first one we'll look at is a polynomial question where we have to use the factor theorem. This is the question here. I've stuck it on the front page so you can see it easily. So we've got a polynomial given to us with this thing here. That's a brilliant start, isn't it? Let's see. There we go. And a is a constant. So there are a few bits to it. First of all, given that x minus 2 is a factor, we have to find the value of a. That's going to be an easy factor theorem problem to solve. And then we have to go on and factorise p of x. And the last bit is the interesting bit. Find all the roots of the equation p of x squared is equal to 0. So I'm going to talk about this one now. Here, we've got a polynomial written as p of x. And if you think back to what that means, it means that we're taking a value of x and we're chucking it into a function machine, right? And it goes through the function machine and out comes p of x. So when we've got p of x squared, all that means that instead of putting x into the function machine, we put in x squared, which means that we're going to replace x in here with x squared. I've probably just made that sound worse than it is. It's actually reasonably straightforward. So let's start by finding the value of a. Well, we know that x minus 2 is a factor. That means that we know that p of 2 is equal to 0 by the factor theorem. So we're going to substitute that in and solve. So p of 2 is equal to 8 minus 6a plus 4a, and that equals 0, giving me 2a equals 8, a equals 4. So now that we've got this, we can substitute that back into the original polynomial. So p of x is equal to x cubed minus 3ax plus 4a. That gives us x cubed minus 12x plus 16. And now we have to factorise fully. But that's not bad because we know one of the factors is x minus 2. So with this one, I'm just going to do it by inspection because I know that I have to get x cubed here. So this must be x squared. So matching up now, if I multiply this out, I'll get minus 2x squared. I need to undo that. So we're going to have a plus 2x here, right? So that gives me 0x squared because there's no x squared back up here. Lastly, I've got negative 2 times what, giving me negative 16. That gives me minus 8. Now, there are other ways that you could have done that matching up, and you can check that it all works out, but it does. So factorising that, we get x minus 2 times x minus 2, x plus 4, which we can write as x minus 2 squared times x plus 4. So that's fully factorised. The last bit of the question requires us to find all of the roots of this equation here. So as I said at the start, we're going to take the x's in my polynomial and replace them with x squareds. Obviously, it makes much more sense if we're trying to solve an equation equal to 0 to do that with factorised form. So we don't want to go back to this version and put in x squared, because that's just going to create confusion and work. Instead, we're going to work with the factorised form and say p of x squared is equal to this. X squared minus 2, all squared, times x squared plus 4. And that needs to equal 0. So as usual, either this equals 0 or this equals 0. So x squared minus 2 equals 0, gives me x squared equals 2. X is equal to plus or minus root 2, and here we get x squared is equal to negative 4. So x is equal to plus or minus root negative 4, which gives me plus or minus 2i. So there you go. I quite like that question. It's a little bit different, and it just checks that you really understand what a function is, I guess. So it links back to all that nice stuff in AS about one-to-one and inverses that we don't really look at much in Pure 3. Okay, I'm going to do these questions as separate videos, so that's all for now, but I'll be back very soon with this one, which is a complex number question.